And now I would like to invite Mr. Peter Bednár from the Technical University in Košice, who will talk about artificial intelligence in insurance, strategic transformation, and emerging paradigms. Unlike my colleague, I will talk about the history in the past 25 years, so I would like to start with my own history. I did my PhD study in AI, then I worked for several years as a assistant and researcher in different projects including insurance industry, and then I took a slight detour into informatics. I applied the processing of a natural language in a domain where you need to scale up the processing into millions of texts, and you have to extract relevant and accurate data, because that's important, obviously, in healthcare. And at the moment, I work as in our institute in the Technical University, and I'm interested in the evolution of AI and in the way how it reached this stage, the architecture it has, and why I would like to talk about it. I think it's quite useful for us to make us aware of certain associations and to be able to forecast certain trends and to see what's important in this area. So let me start with the first period that talked about the fact that for the first time we had certain tools like machine learning and the ways how to analyze data. And obviously we're aware of the fact that data are key for insurance industries. And we obviously worked on certain things like prediction or evaluation or pricing of different products. But all these projects were based on a standard methodology where we had to go through standard procedure and steps, the modeling, evaluation, etc. And the nature of the data present in insurance industry, there are different models. You have text documents, non-structural data, images, and structured documentation. And that represented one of the big issues because the process of pre-processing of the data to make it into a structural form for us to be able to make predictive models that would support decision making. So this process was very complicated and pricey. So I wouldn't say that those models were unsuccessful or unnecessary, but I would say the percentage of projects that would reach a profitable outcome was not that big, and it was really costly to work with those data, and it was quite limited. So the first huge leap in AI was with the onset of deep learning, where the basic paradigm changed in a way where we would not create some science, or it would not have to be processed by a data analyst, but all this would be included in learning, and we would create an architecture of, for example, neuron networks. And of course, since these models became more complex, to train them we needed more data, so we had to wait for several decades so that the algorithms that were available could be used to solve real problems, because we already had enough data for training and also the architecture or the infrastructure to do the training. But what was important was that we made a breakthrough in the issue of processing of untrained data, and we made a breakthrough in the processing of image and natural language. And that was the first key moment where we managed to make more efficient these decision making, or the structure of the decision making models. And the new paradigm consisted in the fact that these models were not developed for a specific application, and to train these complex models, we needed more data, and the development was such that we had a data trained for one problem, and we tried to adapt them for specific problems we needed, for example, for medicine or insurance industry. That means that the development of AI-based solutions depended on the fact that we already had some basic models that were trained, and we tried to adapt them. And this is what we are doing still now. This is the basic way of implementing the current systems. As I said, the development continued. The models were started to be merged. Now we have multimodal models, and they can process images, text, or there can be some logical inference or something. And these are more complex systems that can process more modalities. And what's important is that we can communicate with them in the natural language, because this had been a long-term problem before. And that means that our interaction has changed. So we communicate with these tools in the programming language, and our way of interaction has changed, as I said. We have a visualization of certain signals, or there is a recommendation, or sorry, we do not have a recommendation in the form of some predictions, but we can describe very complex solutions using very complex but natural language. So this shift has been very important also because as part of outputs, we can have the explanation of the solution. And if we are able to validate and accept this solution, then we trust them more, obviously. Obviously, these models have their issues depending on the way they're trained. For example, they won't be able to provide current data or up-to-date, updated data or hallucinations. Another issue is they are quite difficult to be modified and to add more properties because there is a concept of certain forgetting of previous knowledge. But we have prepared several possibilities or options that also some common companies use in the use of these models. And what we can do, that we can just extend or make more precise our requirements, but we cannot build on their capacities. For example, prompt engineering, or we can do some partial training, but there is also common ways of training like RAG or CAG. And so, for example, you try to search for all the information for the entry into this generative model, but you won't be able to train or to teach that model something new. You will just use the properties the model has, and that this model is something that this model already knows. It's quite useful, but obviously there are limits to it. And on the other hand, what we have is that normally these models are based on machine learning, so they can be, there can be further, change in training and in terms of the data. And here we are talking about like fine tuning. whether full training, and there's a question how to train this model for a new set of tasks, for example, and there can be also some more effective methods like adapters or soft prompting, where we just change parts of the parameters of this model and we can teach it some new ability. So this was like a common state, I would say, and this is the way we work with the models. We need to work with them. And now, well, we move on and to agentic AI era. This is not new. I mean, these basic terms were also examined and researched in the 80s, and the basic structure of an autonomous agent that will help us with decision making. It looks like this. So there are steps of planning and considering what should be done. The agent divides it into several steps or subtasks. Then it's the execution of the tasks, the interaction with the environment, for example, the access to the databases, the getting of the necessary data from different data storage sites, and the integration of the data, so the interaction with the environment in the industry, and then the observation. So I evaluate, I assess the data, the state of, the stage of the solution, and then I can carry on with the task. So this is the way the agent system should work, and these independent autonomous systems to support decision making. And we can only see a different extent or different level. The levels, which have been trained in a language model and which are, for example, in hybrid manner, have been pre-programmed, and are kind of fixed and can be validated quite well. So we have like a scale or a range between a well-defined formal working talks and rules, and on the other hand, we have full autonomy, and they are based on generative models. So I would say this is the structure.
So when it comes to the research, the scientists have the ambition to create an AGI and to create an independent autonomous system, which is all fine and well. But if you look at the application, especially in the insurance, we have to stay in the lines due to the very strict regulation. And one of the basic asks is to have a system that is auditable and transparent. So this means the basic requirement is quite basic. We want a person to be able to prove, to think about what the system actually does. So yes, based on these circumstances, I would also make the same decision like you. Thank you for bringing this up. So this is something that we are looking for. It's quite critical also for the applications that have some ethical elements attached to it. This is something that is not avoidable. This will become the reality that will also limit our research. It's not that we wouldn't be able to create a big autonomous system. I would not underestimate the science in that way, but when it comes to transparency, we will be able to choose a different strategy. What is the strategy? So we want to understand the system. Why did it come to a certain conclusion? The first question is the system telling us the truth? May we rely on it without bias and so on and so forth? To a certain extent, we may verify it. The system itself is able to create a description in the natural language that is readable by a human. It's not that important internally how the mechanism is implemented, it's just more of a philosophical question. More important is when a person reads it and it makes sense, and he or she would make the same decision under the same circumstances like the agent. When the person is able to understand and accept this, we may accept that this is a valid outcome. And another problem is the completeness of the information, which is not as easy to validate. We have multiple models extracting certain type of information, and when this information is, for example, that is important, is missing, this model will not bring us to our attention, for example. This is a very difficult issue. How to detect such cases? The only thing we can do is similarly as in humans. We will create a hierarchy of control checks, and one agent can check or another agent to be able to verify its outcomes. So it will be specialized for the verification. So in order to make it transparent, we have created schemes as such, and a lot of terms that have been mentioned we can find here. For example, the orchestrated AI that has very well predefined rules to kind of guide the entire process. So it's a very specifically done architecture that is easy to interpret and to check. We can formally validate these rules, whether they are not contradictory, and etc. So this architecture is usually generative and based on strict regulations within the processes of insurance. I would not change it. These are really normative processes that we have to follow. So there is no freedom for autonomy, and it is not important to infer these processes into a language model of generative model. So this is based on a knowledge by engineers with strict information that is verifiable. So for more difficult tasks, for example, if we were to plan a dynamic access to certain information, it would be useful to have a planner, some components that is able to divide some more difficult processes and to plan specific steps. But within this process, this part, we have a large playground to use certain processes. It's not always necessary, especially if we are able to implement the entire basic process in the orchestrator. It's not necessary to use the dynamic planning. We will need a lot of models that are processing the data itself and pre-processing the decisions themselves. For the models such as models for image processing, language models, RAG systems, and so on and so forth. So there are components dealing with the solutions of the tasks that we need to solve. Another important component is the last one, which is the models focused on checking the outcomes. The majority of the systems with such architecture will be transparent. So if we take a difficult problem and we divide it into the specific steps, it's easier for us to check the context, because if we are missing an information in the decision-making process, it's easier for us to automate such process. So if we want a scalable solution, the check of the models themselves is automated. So now we take the concepts model as a judge when you are taking the output of the system and comparing it to a different system. So you are trying to check the negative outputs or inferences of the generative models, but specifically the completeness of information, which is the most problematic and most critical one. As I have already said, in the model of the critics, it is not a homogenic technology. where there are only strictly the components based on the machine learning. You can also use the formal algorithms as well. To a certain extent, in every step, also a human can be part of it, but if you're trying to automate it as much as possible, you have to have specific components within your architecture dealing with the validation. So to sum it up, to have some time for questions at the end. And I think the following presentation we need a little bit more time. Maybe the first thing. Currently, it's not as much of a problem what the AI cannot do. It can probably predict and to do a lot, something that we have not expected 15 years ago, for example, the natural language processing. Now we know that somehow it is working. So I would say, for the first time also in our field, we are no longer asking ourselves how should we do something or if we do it. So there are more ethical problems that we are dealing with now, which is also connected to the issue how we are limiting the architectures. It is interesting to create a completely autonomous system with an AGI, which is our goal as researchers. On the other hand, when we talk about practical applications that are strictly regulated, we have to limit our architecture on purpose and to concentrate on aspects such as validation and transparency and so on and so forth. It is good that we have such regulation in place. It is also an interesting impulse for research, which is now for the first time that some European standard is defining some limits that are motivating the researchers for them to look for solutions that they necessarily wouldn't have to look for. So this dimension is quite interesting as well. What is also important in insurance, you have no choice. You have to act ethically and you are strictly regulated. But what I want to say is that should be also the case in every system that we are designing. So to sum it up, it's also what the other speaker said. It is not a problem that we are not able to create something, because I'm quite an optimistic. We will be able to raise the autonomy of specific systems, which is quite okay. But the future will be about intelligent recommendation and collaboration with the expert. So we will not replace the specific expert. We will create a co-pilot or a partner that will be more or less on the same level when it comes to reasoning and understanding of the problem and the processing of information. Without that, we won't be able to build the trustworthiness. And this is extremely important for these types of applications. So much from my side. Thank you so much for your attention.
Ďakujem pekne pánovi Bednárovi.
Thank you so much, Mr. Bednár from the Technical University in Košice. Does anybody have any questions? In terms of current trends in development of the agents, what is the trend? So is it now to fine-tune the agent? Now, since there is a high robustness of the LLM, we are looking more on how the agent is behaving. So one thing, as I said, is to improve the abilities of the generative models as such, so machine learning. But a very active area is hybrid systems. As you have seen in the presentation about autonomous vehicles. We combine some mechanisms and a knowledge of reasoning modes such as logic, and we connect it with some mathematical inference that is based on machine learning. So more of hybrid models that have way higher transparency and they are way more auditable. So this is one area. But as I said, both of these areas are active and comparable. For the insurance area, the hybrid systems play a very significant role, especially specifically for their accuracy. Thank you.
Ďakujem. Máte niekto iný ešte?
Any other questions from our audience?
Môžeme sa ešte spýtať pri tých expertných systémoch.
So when it comes to expert systems, when the AI or the agent communicates with the expert, what is your view on the responsibility dimension? Because the human will be still the responsible one. Let's say it will have the person has 1,000 requests, and when something goes wrong, somebody says, "Oh, you were in charge for it, so you were the one who was supposed to validate it." So my question is, we still used to have an expert system. We used to have algorithms where you saw how it works, but now you have an agent that basically deals with it on their own. I think this question is a little bit more complex because we want it to be more auditable also from the methods of LLMs and machine learning. So also part of the AI Act is the limitation to the fact that we have to be more transparent also in terms of training data. So how much we expect them to be auditable, and this range we are expecting to grow. This is also in regards in all of expert systems. Also about the LLMs, where we have millions of parameters and we want to minimize the probability of some negative effects. And then we have an area with very high transparency. So this is a very difficult problem because when you have clear training data, even then, the model has such a capacity so it doesn't make any wrong decisions. So, of course, we're trying to minimize the risk, but it won't be only about the risk minimization. That's why it's important to make the architectures very robust with specific components that will be scalable, and they will be verifying our outputs and again verifying these specific outputs to reach the probability that is high enough to be almost sure that there is no mistake. This is more of a issue in terms of processes, how to translate this responsibility in terms of probability of making mistake. So before we had LLMs, and then we had the experts. Yes, it's true. I started with semantic technologies, and now this is more based on LLMs. So there is statistics, but it's based on the context. So instead of accurate algorithms where we are calculating a specific data, it's now different. No, it's not necessarily the case. When I was talking about the hybrid system, the connection between ontology and the interference and the natural language processing within the inference of a language model, to a certain extent, we are able to very strictly limit how the model generates its outputs, and we are able to lower the risk of hallucinations in the models that are auditable. So again, thanks to this architecture, we have again moved the limit where there will be a probability of some faulty reasoning. Again, this is still not enough. We need some independent components that are part of the architecture design itself to make the entire system even safer.
Microphone, please.
Takže Otázka, ako som ja vnímal od
So the question, the previous question, I perceived it as, what will happen to the responsibility or liability of that expert, possible legal consequences of their decision if, under those new circumstances, that person will use the output of an LLM system, will base his or her decision on it. So whether any legislation covers it or will cover it? Do you know whether there's any plan? Well, it's not really a question for me because I don't deal with these legislation matters. But obviously, it's like with a liability in when driving autonomous or semi-autonomous vehicles. It is still about the driver who has the responsibility. I would say that right now there isn't full transparency as regards the transfer of the liability from the driver to the either provider of the system or the designer of the system. So there may be a failure, obviously, and I would say that from the legal point of view, it may be quite complicated, but I'm not a legal expert or an expert on the application of AI solutions. Yes, I understand. Yeah, but well, it seems that right now the liability is with the user, because obviously there is this like disclaimer. You always have to check the results, and so it would be interesting to know what the legal consequences could be.
Zobral tak pragmaticky. Určite sa to takto nebude realizovať.
I would be quite pragmatic. I don't think that it will be in this way, but obviously humans make mistakes as well. So if there is a legal way of doing the audit, for example, in your case, if I want to appeal to the decision, if I want to appeal the decision of the insurer, then I can do that. And obviously there are some control mechanisms and there's an expectation that there may be an error, and how many companies will make the effort to assess the performance and to see of their staff and to see whether they have made the mistakes. And sometimes I don't see that kind of evaluation or assessment as a basis for comparison. So what I can do is to try to minimize the error, the occurrence of the error. But if I know that there is a certain error rate that is possible, I will have to combine it with the probability of a human error in the judgment or the decision. So I would say we should look at how reliable are people, and I'm not saying that people are not reliable. Well, humans are all we have. The microphone, please. The question cannot be interpreted without the microphone.
To je pravda.
OK, ďakujem pekne. A máme...
Thank you very much. And we have a Slido question. Is it possible, do you think, that any insurer could create an AI solution that would push out all others from the market? Well, I don't feel qualified to answer this question. I don't think that just one insurance company would be able to make such a huge leap, and just a single company. I think there will be, more companies using it. Obviously, I don't think that it wouldn't be a good strategy to ignore the existence of the AI, but I don't think that one single company would be able to dominate the market thanks to a magic AI solution or by magically applying an AI solution. Well, these technologies are quite open, and I think we are quite dependent on the technologies that are not developed in Europe. And I think this is one of the issues. I think Europe needs to step up its efforts, but I say I don't think that there would be one single company that could, I don't know, kind of explode in terms of its abilities and capacities on the market. I don't know, maybe the representative of Gratex would be able to say more. Thank you. A round of applause for Mr. Bednár.